involving a function, two instances of an unknown function. Now, there's a key idea here that makes this thing solvable. It's the only way to solve it that I know of. Let's say that we have a function g of x. Call it g, not f. And let's call it 4 minus x, which you'll note is the input argument. Now, it turns out what makes this thing tick, what gives us a way to eliminate this term right here, is to note that g, in other words, g is its own inverse, is what I'm about to write down. G of x is equal to x, and this is literally the definition of what it means to be an inverse function. And it turns out in this case, this function is its own inverse. Okay. Now that truth will help us to figure out how to eliminate this term. Because really it's two instances of an unknown function, and no, it's not the one hiding behind the bush. We need to figure out a way to eliminate this term. And then we can get an expression that involves only f of x. So we use this truth right here, replacing x with 4 minus x, which is effectively what this is doing formally. We end up, and again, we replaced x with 4 minus x right here and right here, right? And we get this statement here, you see, f of x plus f times f evaluated at 4 minus x, which is essentially the opposite of this. But we have to replace this x with 4 minus x, this x with 4 minus x, and this x with 4 minus x, which is what is happening right here. Now, y'all, I saved you the trouble here. I left out this expansion, and this expansion. I don't think you want to watch me do that. And double check this. You get this expression right here, which is a cubic polynomial. Okay? But now we have a way to eliminate the f of 4 minus x term. In other words, again, our goal from the beginning has been to see if we can eliminate this term. Well, this multiplication will allow us to, if we multiply 5 times this and subtract it from the expression that already has a 5 as the coefficient, the f of 4 minus x terms will go away. Okay? Now, y'all, when you do this, you get 24f of x, because this would be 5 times 5, which is 25, minus 1 copy of f of x is where this 24f of x comes from. Okay? But then we have to subtract off what I've written down. Now, I've just written it down for you. 5 times this object minus this object right here. One of them was our given, remember? So all you have to do is perform the subtraction and solve for f of x. Now, you'll notice there's a lot of cancellation right here. This is 20 times x cubed minus a minus 4x cubed, which it gives you 24x cubed. Okay. Now let's see here. We have 5 times 12, which is 60, but that gets offset by this 60 right here. Remember, we're subtracting. So there's no squared terms. Okay. Next is we have 5 times minus 40. Well, that's negative 200, but it's minus a minus 248, so we'll get plus 48x. Okay. And then also you'll note that 5 times 72 is the 360 you see here, so the constants go away. So you see we end up with 24f, I'll just recopy it right here, 24f of x, and we are hunting for, that's the neat thing about functional equations, they're unknowns in this context. Okay, so we have 24f of x equals to all this, but it becomes very clear that f of x, when you divide by 24, we get x cubed plus 2x is our answer. Now, a lot of people that do these, I've noticed a lot of the math channels that do this, just stop right here. But it's worth your time to try to check your answer. You know, I mean, you can crow all day long about how I think I have an answer. Let's come up here and check this. This says x cubed plus 2x. Okay, now, so we found our function. The answer, or the answer that we're positing is f of x equals to x cubed plus 2x. Now, a necessary but not a sufficient condition is to try some easy constants here. Now, so we'll try 1. 0 is pretty obvious. You can check 0 yourself. But notice that if you do x equals 1, let me make sure I have enough room here. Let's try x equals 1. That's the next easiest constant than 0. Okay, this implies, okay, this would imply that f at 3 see, y'all, I'm taking this 1 and placing it right here. And then plus 5f at 1 plus 5f at 1. Okay. And y'all, I'm going to put equals with a question mark here. It's not an assertion, it's an interrogative. Okay, so that would be, put a 1 right here, you get 4. Put a 1 right here, you get 12. Minus 40 plus 72. Okay, now f at 3 is 27 plus 6, so that's 33, right? If you put a 3 right here, you get 27, all right? And then 3 right here, you get 6, 27 and 6, so this part would be 33. I'll write it directly above, okay? Now, f at 1 is even easier, right? 1 cubed plus 2 times 1 is 3, 5 times 3 is 15. So, folks, you can see the left-hand side adds up to 48. 33 plus 15 is 48, right? Now, do we get 48 over here? Let's check. 4 plus 12 is 16. 16 and 72 is 88. Minus 40 is 48 over here, folks. Okay, so good for us, right? We got it. Now, this, again, is not a conclusive proof, but it's very, it's a nice sanity check, okay? But I think we got it right. It does work for 0, which is even easier to show. So these two objects are equal to each other, right, for the choice of 1. Now, it's for all 1, but you can try any other number. The other numbers are harder, of course. You know, maybe -1 would be an easy check, okay? But in any event, this is what I'm claiming is our, and you can actually check it more generally than what I just did, but I claim this is our missing function. F of x is equal to x cubed plus 2x. Okay, thanks for viewing.